Hi, today we are talking about one-step equations using multiplication or division with negatives. Our goals remain the same. We want to isolate the variable, get it by itself, and keep the equation balanced, which means what you do to one side, you must do to the other side of the equation to maintain the equal sign. The multiplication property of equality and the division property of equality basically say that if you multiply both sides of an equation by the same number, or divide both sides of the equation by the same number, it will still remain an equation. It'll still be equal. Okay, so here we have example 1, parts A and B. In part A, I'm just going to rewrite this so that I have a little bit more space here. I'm going to draw my line, and I'm going to highlight the variable to show that I want to isolate it. Now, I read this as x divided by 3. So in order to get rid of dividing by 3, we do its opposite, its inverse, which is multiply by 3. These cancel. That leaves me with x equals, we have a negative times a positive, gives me negative 18. If you want to check your answer, you can plug this number back where you highlighted the x. Negative 18 divided by 3 is negative 6. Okay, part B. I'm just going to rewrite this again. Draw my line, highlight my variable. So this reads 18 equals negative 4 times y. Well, I want to isolate the variable, so I need to divide by negative 4. Because negative divided by a negative is a positive. We want y to be positive. And 4 divided by 4 is 1. We want 1 positive y. What we do to one side, we do to the other side. So this gives me y equals. Now, we know that a positive divided by a negative is going to result in a negative number. We also know that this is a way to write improper fractions. So rather than doing the division, we can just change this improper fraction to a mixed number. So 4 goes into 18 4 times. That brings me up to 16 with 2 remaining. So our final answer, I'm just going to simplify this, is negative 4 1/2 equals y. And again, you can plug this back in and do negative 4 times negative 4 1/2 to check them to make sure that you get positive 18. Okay, example 2. I'm going to rewrite this. We're going to solve equations with reciprocals now. So we know reciprocals are when you flip the numerator and denominator of a fraction. And we know that when we multiply reciprocals, you're able to cross-cancel everything. So if we're trying to get rid of negative 4/5 because it's being multiplied by x and we want x to be by itself, we are going to multiply by 5 over negative 4. Again, the reason that I'm choosing to make one of these numbers, any of these numbers, negative, is because I want to result in a positive x, and a negative times a negative becomes positive. So this part cross cancels and leaves me with x, and we need to make sure that we're doing the same thing to this side. I'm going to make negative 8 into negative 8 over 1. I cross cancel, and that gives me x equals positive 10. Because 2 times 5 is 10, 1 times 1 is 1, negative times negative is a positive. So we get positive 10. Heading over here, we have Negative 6 equals 3/2 times z. I want the 3/2 to go away, and I know I can do that by multiplying by its reciprocal. What you do to one side, you do to the other side. The 3's cancel and the 2's cancel, and that leaves me with z by itself, which is what I was trying to get. I'm going to put negative 6 over 1 to make it into a fraction and cross cancel. Now I just multiply across. 2 times 2 is 4 over 1 times 1, so 4. And we have a positive fraction times a negative fraction, which will give me a negative 4. And again, you can plug negative 4 back in for z and check to make sure if you did this multiplication that you would get negative 6. Okay, final example. The temperature at midnight is shown at the right. The temperature decreases 4.5 degrees Fahrenheit each hour. When will the temperature be 32 degrees Fahrenheit? So if we look here, right now we are at 56 degrees. So that is our starting point. We are decreasing 4.5 degrees Fahrenheit for each hour. Now let's see. The temperature at midnight is shown, and we want to know how many hours, so I'm going to say times h to represent how many hours, because we don't know, it doesn't say in the problem, will we result at 32? Will we get a result of 32? This is a two-step equation. We've done those before. Let me remind you, we're going to use SADMAP. So we're going to get rid of this number 56 because it is being subtracted by the term with the variable in it. Now this is a positive 56, and I'm actually going to do keep change here, or add the opposite. Because when I get rid of this positive 56 by subtracting 56, you're going to notice something. So subtract 56 from both sides. It's going to give me negative 24 on this side. But what we notice about what remains on the left side of the equal sign is that we have a negative 4.5 times h. Negative, because we did keep change. You might not have recognized that this is taking away 4.5 per hour without having done the keep change. So that's an important thing to just recognize. Last step, we're going to divide by 4.5 on each side, negative 4.5. That cancels, and this leaves me with h equals 5 and 3 repeating hours. You could also write that as 5 and 1/3 hours. And I'm actually going to write, let's see, this is past midnight. So if we're at midnight, 12, 5 and 1/3 hours for it to be at 32 degrees Fahrenheit. So that becomes 5 a.m. and 1/3 of an hour is 20 minutes. So it's going to be at 5:20 a.m. 5 and 1/3. 1/3 of 1 hour is 20 minutes. 1 hour is 60 minutes. 1/3 of that is 20 minutes. So 5 hours and 20 minutes past midnight is 5:20 a.m. And that is the end of the one-step equations using multiplication or division with negatives notes.